This is the last example for section 1.4 day 2, and you'll notice that this is an application problem. This is number 34 on page 117. So I've just taken this directly from the book. It's not one of, it might be one of the problems that you're doing in your assignment, or just really, really close to one of them that you're doing in your assignment. So here's the problem. It says New Age Special Effects prepares computer software based on specs prepared by film directors to simulate an approaching vehicle. They begin with a computer image of a 5 by 7 by 3 centimeter box. The program increases each dimension at a rate of 2 centimeters per second. How long does it take for the volume of the box to be at least 5 times its initial size? Well, we have one thing that you should see that pops out here is volume. We're going to be looking at volume of a box. Now, volume of a rectangular box can be covered by having this formula that you probably remember. Volume equals length times width times height. That's just our basic volume formula. And this whole problem, the reason we're doing this application is because it kind of connects to the idea of compositions of functions. So this is our basic function. Now it says here that it's initially we have a 5 by 7 by 3 centimeter box. So 5 times 7 times 3 is going to be our original volume that we're looking at. That original volume happens to be 105 cubic centimeters. So we're going to use that as a starting point here. Now it says in this program it simulates an approaching vehicle. The program increases each dimension, these are the dimensions we're talking about, at a rate of 2 centimeters per second. So if we use a variable t as in terms of time in seconds, then you'll notice over here that I've got an expression for each one of those dimensions. Now the length I'm calling the 5, and it increases at a rate of 2 centimeters per second, so 2 times t. The width and the height are exactly the same because they're all growing by a rate of 2 centimeters per second, and that will affect how the volume increases on this box. Now the way this connects to compositions is that we're going to take each one of those and substitute them in for L, W, and H in this volume formula. So we've got the volume equals, in this problem, 5 plus 2t times 7 plus 2t times 3 plus 2t. And we want to find out when, or how long does it take for the volume of the box to be at least 5 times its initial size. It just keeps growing. And so any time past the point where it's equal to 5 times this is going to also work. So first of all, what is 5 times 105? Multiply that, it is 525. So we want to find out when 525 is equal to this function. So we still have all of this. I would not recommend that you FOIL all this out because that'll be a lot of work. It's just not quite worth it for what we're going to do on this problem. I'd recommend that we use a graph to solve this. Now if we're going to use a graph, probably the easiest way would be to set this side equal to 0. So I'm going to move this over. I'm going to subtract that to the other side and say 0 equals, again, all of this stuff. Shouldn't have to keep rewriting it, but it's just one more time. Minus the 525. All right, so there's my equation, and what I can do with that, if I want to find out where this is equal to 0, I can solve that using my graphing calculator. Here's what I'm going to do. I'm going to go into y equals, and I'm going to plug this in the right-hand side here. I'm going to plug that into my y1. So if I graph this and take a look at this graph, you'll see that it crosses here at that value, whatever that happens to be. That's the value of 0. So we are looking for 0. We're going to find out where it just crossed the x-axis. And so to figure that out, I'm going to go to second trace to get the calc menu. I'm going to go to a 0. Now here's where it's a little tricky just to see what all is going on. You'll notice it says left boundary. The cursor is at 0, so we could hit enter there because we know it's to the left if it's at 0. This one is, somewhere in between 1 and 2. So I'm going to hit enter. Then it's going to ask me for a right boundary. I'm just going to move the cursor over until I'd say it's at least 2. That should do it just fine. You'll notice that it's over now on this side, way up there. I'll hit enter again. I'll just move 1 click back to get close to it. Hit enter again. And it tells me here that it's at about 1.62. So this is telling me, even though I used X instead of T, that we're at about 1.62. Time in this case is in terms of seconds. So at 1.62 seconds or later is when the volume of this box is going to be at least 525. And that will be very similar to a problem that you do in your assignment tonight.